So good morning, welcome to SAKALAVIDYA YouTube channel. Uh, Today joined Shyam, Manoj, Swati, Vamshi, Manjula, Suma, Vamshi Krishna Yadav, Swati Singh, Swapradeep, Joseph, Prasanna, Karthik, Shamala, Jingam Shamala, Swati Singh. So good morning all. Okay, still we have 5 minutes time. So sharp 9:10 we will start the class. Manoj Kumar Chintu. Okay. Mukesh Vandanapu. So any new viewers are there, like, subscribe and share. So Gorla Viranjini, Satyanarayana. Okay, you need to concentrate till the completion of my session. B Chalamaya. Yes, you know, Vamshi, regular, you are regular. I know. Irfan Ali, you seem to be new. So Karthik is regular. Chalamaya also. Velmur Satyanarayana is actually new. Swati Singh is regular. Vamshi Krishna regular. Shyam also regular. Manoj, Karthik, Suma is regular. Manjula, okay, Vamshi Krishna Yadav, right. So today topic will be continued. Akash Vankayala, new. Okay, till the completion of the session, you need to concentrate. Deepika, you are also new. Siva Ganesh. So that depends upon you actually. The core branches, civil, and next electronics and mechanical are the core branches. The rest of are IT and CSE. Fine, 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 fine. Krishna Teja, Sujan Kumar, we are gaming zone. Maroj Sadvika, Govind, after a long time. Oh, yesterday, yes, you were there. Yesterday you were there. Krishna Teja, okay. Suma, fine, Suma, fine, fine, fine. Just somewhat little bit. Okay. Suresh Gurram, okay. Okay, today it's good. Today it's good. Okay, it might be, no problem, no problem. But all of you, I asked you to go to the below description and give your comments also. I already told you, but I am getting only few from few of you. So very good morning, Suresh. Suresh. Okay. Vaibhav. How are you, Vaibhav? No problem. Still 1 minute time is there, Vaibhav. Sai Charan. I don't have the idea because uh, we should not disclose such information to you because authentic information should be given to you. But some of the YouTubers may give the news, but we should not do like that. So that you need to check the newspapers or any news, relevant news from your respective sites. You need to see it. So my suggestion is that actually don't follow such fake news. That should be confirmed. Unless we should not say. Right. So one thing, all of you, important information to you, whether it may be postponed or may not be postponed, but this concept is very important to you. So it will be useful even life also. So that's why, so you need to concentrate on that one, because being a mathematics MPC group or MEC group, whatever group is a mathematics related group, it will be useful in your coming future also. Definitely you will remind me on that day. Okay, leave it about the Eamcet and etc. So your sweat and toil never waste. Just target you remember now. So understood now? Okay, Sam has given start. Let us start. Okay, let us start. Sam is very intelligent, but everybody is very intelligent. Okay, that's everything. That's why official site you need to concentrate on that one. Right. So now ellipse part 4. Today is the part 4. What is the question number? Anybody? Question number. Pramila. Where have you been? Swati. Manjula. What is the question number? Suma, Narla, Dishwank, Govind, Vamshi Krishna Yadav, Swati. Okay, 42. 42. Because I need to check your. Yes, thank you, Vanadal. Thank you, Sam. Thank you, Govind. Vamshi Krishna. Chalmaya. Yes, 42 or 43? 42nd. 42nd. Right. If alpha comma beta are the ends of a chord, ends of a chord of the ellipse x square upon a square plus y square upon b square equals to 1, which cuts the major axis at a distance of at a distance of d units from the center C, then tan alpha by 2 multiplied by tan beta by 2 equals to, first option is d minus a upon d plus a, second one is a minus d upon a plus d, third d plus a upon d minus a, fourth d minus d plus a upon a minus d. So this is the question. Right. Thank you, Kasim. Thank you. Raut Wayne. Alpha, beta are the ends of a chord of the ellipse S is equal to 0, which cuts the major axis at a distance of d units from the center C. Then tan alpha by 2 into tan beta by 2 we need to find out. That means if alpha comma beta are the ends of the chord which cuts the major axis at a distance of d units from the center C, then we need to find out tan alpha by 2 into tan of beta by 2. Okay, let us do it now. 40-second solution. 40-second solution. See, this is the ellipse center. That means origin only 0 comma 0. So this is the chord. For example, say at P of alpha, this is Q of beta. It cuts this is the major axis, x and x dash. So at d units from center, d units means the coordinates will be, this is d comma 0, d comma 0. That means it passes through d comma 0. First, our plan is we need to find out equation of the chord joining the points alpha, beta. We need to write it now first. After that, substitute d comma 0. Then tan alpha by 2 into tan beta by 2 we can find out. That's the plan now. Write down equation of the chord, equation of the chord joining P of alpha, that means parametric form, and Q of beta is, that is given by x upon a cos alpha plus beta by 2 plus y upon b sin alpha plus beta by 2 equals to cos alpha minus beta by 2. According to the problem, it cuts the x-axis at d comma 0. D comma 0. Since it passes through, that means because from origin the distance is d, that means on x coordinate, on x-axis the coordinates will be d comma 0. Okay, it passes through d comma 0. That means instead of x d, instead of y 0 substitute. Now we get like this now. That implies d upon a cos of alpha plus beta by 2 plus 0, 0 by something 0, 0 equal to cos of alpha minus beta by 2. So that means d by a cos alpha plus beta by 2 equals to, we can write cos of alpha minus beta by 2. So this we get it now. So with the help of this we need to find out tan of alpha by 2 into tan of beta by 2 using applying CD rule. Okay, where is Suma? Where is Narla? Where is Dishwank? Where is Balu? Gopalam? Surya Prakash is not coming. 42. 42. So that means we have d by a cos of alpha plus beta by 2 can be written as cos of a plus b form. Cos of alpha by 2 plus beta by 2 equals to, This is cos of alpha by 2 minus beta by 2 we can write. Now the d by a equals to, welcome Rocky Krishna. Yes, Suma is there. Ashwin Kumar, sorry. D by a equals to cos of alpha by 2 minus beta by 2 upon cos of alpha by 2 plus beta by 2. Now apply CD rule. Apply CD rule. Componendo dividendo rule. So with the help of Venkata Raghuram Gonela. Okay, Avinash. So this we can write d plus a upon d minus a equals to numerator by denominator. Numerator plus denominator by numerator minus denominator. We need to write it. So that means cos of alpha by 2 minus beta by 2 plus cos of alpha by 2 plus beta by 2 upon cos of alpha by 2 minus beta by 2 minus cos of alpha by 2 plus beta by 2. So once again let us recall the formulae. Cos of a minus b plus cos of a plus b, that is 2 cos a cos b. So that means we can write a means alpha by 2, b means beta by 2. 2 cos alpha by 2 cos beta by 2. This can be written, even you can simplify also. The denominator can be written as 2 sin of alpha by 2 sin of beta by 2. So now write reciprocal. So if you write reciprocal, you can write d minus a upon d plus a equals to sin of alpha by 2 cos of alpha by 2 upon cos of alpha by 2. This is sin beta by 2. Sorry. Sin beta by 2 upon cos beta by 2. See, sin alpha by 2 by cos alpha by 2 is tan alpha by 2 multiplied by sin beta by 2 by cos beta by 2 is tan beta by 2. So required desired value is obtained. Tan alpha by 2 into tan beta by 2 is d minus a by d plus a. This value is equal to this one. Okay. Sureka, first concentrate on the chapter. So you might have observed all my chapters actually. I don't give the priority for the only important questions. I will discuss each and every model. Each and every model. That you need to remember, Sureka. Option 1. Question number 43. Question number 43. Uppala Sai Teja. Yes. Vishnuvardhan Reddy. If the card joining the points alpha and beta, that means parametric form, alpha and beta on the ellipse x square upon a square plus y square upon b square equals to 1 subtends a right angle a right angle right angle at a comma 0 at a comma 0, then tan alpha by 2 into tan beta by 2 equals to, this is the question. First option, minus a square upon b square, this is plus. Second, minus b square upon a square. Third, b square upon a square. Fourth, minus a square upon b square. This is the question. Right. The chord joining the points alpha and beta on the ellipse x square upon a square plus y square upon b square is equal to 1 subtends a right angle at a comma 0. At a comma 0 means at one of the vertices of the ellipse. Then tan alpha by 2 into tan beta by 2 we need to find out. This value we need to find out. The chord joining alpha comma beta subtends right angle at a comma 0. Then we need to find out tan alpha by 2 into tan beta by 2. First option is a square upon b square. Second is minus b square upon a square. Third is b square upon a square. Next, fourth one is minus negative a square upon b square. That generally we need to say negative. Okay. 43 solution. 43 solution. See, this is the figure. So this is the A, because the major axis a comma 0, this point is. So a chord, you take the chord like this, P of alpha, Q of beta, subtends a right angle 90 degrees here, 90 degrees at A. Then tan alpha by 2 into tan beta by 2 we need to find out. Okay, let us find out now. First, here let P equals to A cos alpha comma B sin alpha. Am I correct? P of alpha means parametric form. Okay, parametric form. Next, Q equals to A cos beta plus B sin beta. It's clear, since these two lines are perpendicular, slope of AP, slope of AQ, product must be equal to -1. So let us find out slope of AP. Slope of AP. Slope of AP. Say M1. Slope of AP. Slope of AP means 2-point form. So that means you can write y2 minus y1. So P of alpha is this one. From a comma 0 we need to find out. Minus B sin alpha upon y2 minus y1. x2 minus x1. y2 minus y1 by x2 minus x1. A minus A cos alpha. So that means minus B sin alpha is 2 sin alpha by 2 cos alpha by 2 upon A common, we have 1 minus cos alpha. This we can write minus 2B sin alpha by 2 cos alpha by 2. So we know the 1 minus cos alpha. 1 minus cos alpha is nothing but 2 sin square alpha by 2. Am I correct? 2 sin square alpha by 2. Okay, right. This we can write like this now. So this we can write now 2a sin alpha by 2 into sin alpha by 2. Sin alpha by 2, sin alpha by 2 cancel, 2 gets cancelled. We have minus b by a cot alpha by 2. This is equation 1. Slope of AB. So now let us find out 43 only. Slope of M2. Slope of here AQ. Slope of AQ is equal to, what do you write now here? That is minus b sin beta. You can write b times 1 minus cos beta. Similarly, this we can write minus b upon a cot beta by 2. Cot beta by 2. Say equation 2. Since AP perpendicular to AQ, that implies M1 into M2 is equal to minus 1. So we can write minus b upon a cot alpha by 2 times minus b upon a cot beta by 2 should be equal to minus 1. This minus minus gets cancelled. We have minus b square upon a square cot alpha by 2 cot beta by 2 equal to 1. So therefore cot alpha by 2 times cot beta by 2 equals to, we have minus a square upon b square. But we need tan alpha by 2 multiplied by tan beta by 2. That is reciprocal of this one. So 1 upon minus a square upon b square. So reciprocal means we can write minus b square upon a square. This is the answer. So Charan Teja, already binomial theorem has been completed. You can check in the playlist. You might be new. First subscribe. Second option is the right option. I hope everybody will understand this one now. 44th question. If the normal at one end of lattice rectum lattice rectum of the ellipse x square upon a square plus y square upon b square equal to 1, passes through one end of the minor axis, then E square equals to right. First option is 2 cos 18 degrees. Second option is sin 18 degrees. Third option is cos 18 degrees. Fourth option is 2 sin 18 degrees. This is the question. If the normal at one end of latus rectum of the ellipse x square upon a square plus y square upon b square equals to 1 passes through one end of the minor axis, then E square we need to find out. Normal at one end of latus rectum of the ellipse s is equal to 0 passes through one end of the minor axis, then the value of E square in terms of trigonometric function we need to write. So let us find out now. 44 solution. 44 solution. This is minor axis, this is major axis. So now suppose say this is latus rectum, L dash, normal drawn at one end passes through the normal drawn like this, passes through the one end of the minor axis. This will be 0 comma minus b. So this is other end, b will be 0 comma b. This is the question. So that means first we need to write equations of the normal drawn at the end of the latus rectum. You need to remember, and it passes through 0 comma minus b. Substitute 0 comma minus b, then find out E square value. Okay, let us do it now. Equations of, this is very important, equations of normals drawn at the ends of, say this is equation 1. Say this is equation 1. Okay, that means actually at L dash, here also one more latus rectum. 4 ends will be there, so that we get 4 equations of the normals. So that is a general equation I have given, but it passes through which point now? It passes through b 0 comma minus b. Instead of x 0, instead of y minus b substitute. So we get like this now, 0 plus or minus b equal to ae cube. So we get plus or minus be equals to ae cube. So we get E square. Plus or minus b equals to ae square. Squaring on both sides. Here very interesting, on squaring what happens means it becomes b square only. B square equals to a square e power 4. Now let us replace b square value. Right. B square means A square multiplied by 1 minus E square equals to A square times E power 4. A square gets cancelled. We have E power 4 plus E square minus 1 equals to 0. It is a biquadratic equation, but in terms of E square it is a quadratic equation. Let us solve it now. So now E power 4 plus E square. Now this can be written t square plus t minus 1 equals to 0. Now it is a quadratic equation in t. So here a value equals to 1, b value equals to 1, c value minus 1. So d equals to b square minus 4ac. Discriminant. So that can be written 1 square plus 4 will be 5. Therefore t equals to now minus b minus 1 plus or minus root d is 5 upon 2. Since t is greater than 0, because t is e square will be always greater than 0. So now you need to take e square is equal to root 5 minus 1 upon 2. Multiply and divide by 2. 2 times we can write root 5 minus 1 by 4. Here very interesting factor, this root 5 minus 5 root 5 minus 5 sorry root 5 minus 1 upon 4 is nothing but sine 18 degrees. So instead of this, replacing sine 18, so we get 2 sine of 18 degrees. This is the answer. Okay. Swati, Vamshi, Teja. Thank you, Tulsidas. Bala Subramaniam. Rajesh, where had you been? Right. "45. 45th question. What does it mean by Gopalam Sai? If the normal at one end of the latus rectum of the ellipse x square upon 25 plus y square upon 16 equals to 1 meets the major axis at G, at point G, and if C is the center, then CG is the distance from center to G. You need to find out. Okay, I will check now. Right. So now the first option, 25 upon 27. Second option, 27 upon 25. Third, 27 upon 5. Fourth, 27 upon 125. This is the question. Sai Anurag, you are new to my classes actually. First, subscribe. Then you can ask me. Right. So Pramila, I have not been feeling well. So I confine to the one class itself only. So then after that I will decide tomorrow onwards. Normal at one end of the latus rectum of the ellipse meets major axis G. If C is the center, then the distance from center is origin to G point we need to find out. Okay. (45) first equation of the, see, let us draw the figure now, first important. This is major axis, this is minor. For example, this is a latus rectum, say L dash, so focus. So this passes through the, like this, G, this is center, see origin 0, 0. CG we need to find out. Sandeep Reddy integration chapter has been completed. Check in the playlist. Check in the playlist. Equation of normal at ends of latus rectum or plus or minus x plus or minus ey equal to ae cube. Say equation 1. It cuts x-axis. This is x-axis actually. Since 1 cuts x-axis, that is on x-axis y coordinate will be 0. So that implies we get plus or minus x plus or minus 0 equal to ae cube. That means plus or minus x equal to ae cube. That means x coordinate becomes actually here ae. That means now the g coordinates will be, you can write like this, ae cube comma 0, because here x coordinate will be greater than 0 in the first quadrant itself only. On actually right of the origin means it will be exponent will be positive. So that means we can consider here x is equal to a cube. So now the distance from C to G is also a cube. That we need to find out now. Therefore now from figure CG is nothing but ae cube. That means problem. What is the problem given actually here? Our problem is x square upon 25 plus y square upon 16 equals to 1. This is the equation of this parabola. So that means actually here a value will be 5, e value, it's important now, root of bigger value is 25, a square, smaller 16, bigger minus smaller, 25 minus 16 by bigger. So this will be 9 by 25 square root, 3 upon 5. Substituting a means 5 times e cube, 3 upon 5 whole cube. This is 5 times 3 cube is 27 upon 125. So 27 upon 5 1 ja, 5 2 ja 10, 5 5 ja. 27 upon 25 is Cg value according to this question. Right. I don't have the, what you have typed, I don't know. Okay. So second option. Second option. Next now. So let us move to the 46th question. 46th. 46th problem. Okay. The length of the chord intercepted by y equals to root 2x minus 1 on the ellipse x square plus 2y square equal to 4 is. This is the question. The length of the chord intercepted by y is equal to root 3x minus 1 on the ellipse x square plus 2y square equals to 4. So whatever concepts we have been discussing on the conic section, that can be applied to the circles also. So understood, Mr. Balasubramaniam? So even you can, if you go through by your own also, you can solve the problems. You solve the problems. If you feel any difficulty, then you can ask me. Right. First option 3 root 6 upon 5. Second option 4 root 6 upon 5. Third 7 root 6 upon 5. Fourth 6 root 6 upon 5. Right. The length of the chord intercepted by y is equal to root 2x minus 1 on the ellipse x square plus 2y square equals to 4 is. Okay. So for this one I will give the shortcut, but everybody asking shortcuts. So I will give the shortcut. Because once again I actually give the suggestion to you, please do follow the concept. Concept is the very important. Definitely after completion of your examination, you will inform me through WhatsApp or anything. So then you will get experience of the concept rather than all these shortcuts. Sometimes shortcuts are also very useful, but beside that, even concept, you need to concentrate on the concept. That's very important. So next time actually whenever I start the classes, actually first I derive the shortcut, then I will apply. That I am going to plan, because the concepts are very very important. But now this time actually I will concentrate on shortcut itself only for this problem. Length of the chord intercepted by y is equal to root 2x minus 1 on the ellipse is 46. What is the given equation? X square plus 2y square equal to 4. Having been divided both sides by 4, we get x square upon 4 plus y square upon 2 by 4 is 2 equals to 1. A square equals to 4, b square equals to 2. Obviously a greater than b. Right. Next chord equation, y equals to root 2 times x minus 1. Comparing with y is equal to mx plus c, that implies m is equal to root 2 and y-intercept c equals to minus 1. Am I correct now? Now let us go for as you wish shortcut or short trick. Shortcut. Length of the chord. So length of the chord to the parabola also I had given shortcut. Now length of the chord for ellipse I am giving the shortcut. Length of the chord equals to 2ab upon a square m square plus b square root over a square m square plus b square minus c square times 1 plus m square. For parabola I have already discussed. See, so no. So parabola is 8 of m square root of, sorry, plus or minus 8. How do we get the 45 and 44 problem? Okay. So that means actually equation of the normal you need to find out at plus or minus ae comma plus or minus b square by a summa. Substitute in the normal equation, you get plus or minus x comma plus or minus ey is equal to a cube. So that was for 45 and 44th problem. Okay. So now let us solve this question now. 2ab, 2 times a means 2, am I correct? B means root 2 upon a square means 4 times m square. M square means root 2 square. Root 2 square is 2 plus b square. B square is 2. Okay. Root of, already a square plus m square is there. 4 into 2 plus 2 minus c square. C square is 1. 1 plus m square. M is root 2 square. 1 plus 2. Okay, you need to simplify. So this equals to 4 root 2, okay, upon 10. 4 into 2 8, 8 plus 2 10. Root of 9, this will be into 3. 2 2 ja, 2 5 ja. This will be 2 root 2 upon 5 multiplied with square root of 9 is 3, but square root of 3 is 3 root 3. So this we get it now. 2 into 3 is 6, root 2 into root 3 is root 6 upon 5. 6 root 6 upon 5. Okay. Ramesh, Ashish Reddy, I cannot do anything. Actually, what my intention is that I need to complete all the concepts and the syllabus, because here today whatever it may be, whenever I start the chapter, I at least more than 75 problems I will complete in this chapter. So my main intention is that it should be useful to all competitive entrance examination, but I will not do once again. So next I will do the level 3 level 4 problems. Okay, thank you. Fourth option is the right option. Am I correct now? Who is Mr. Seshu? It's not personal chat room. Go to personal chat room and you can chat. You can access there. "47. The ratio of the area of the region bounded by the ellipse x square upon a square plus y square upon b square equals to 1 to that of area of the maximum rectangle inscribed in the ellipse is this is the question. So Ashish Reddy, if you give the answer, you will be kept ahead. Right. Madhavi Lauta. First option 2:pi. Second option 5:3. Third option 3:pi. Fourth option 5:2. This is the question. Okay, just go through the question. First note down the question in our notebook. Bhargava, Kapilavayu. After long time, where had you been, Kapilavayu? Are you from Warangal? The ratio of the area of the region bounded by the ellipse to that of area of the maximum rectangle inscribed in the ellipse. Inscribed in the ellipse is that we need to find out. Okay. Gopalam Sai, you are from Assam. Right. So that means first of all, the area of the region bounded within the ellipse is, in areas chapter we have discussed pi AB. That is pi AB. Okay, thank you. So next, maximum rectangle which is inscribed in the ellipse we need to find out. Then the ratio between these two we need to find out. Okay. So now unless we discuss the concept, we cannot do it. I know answer is fourth option, but I need to explain why should we get pi is to 2. So let us do it now. So Yadagiri, I think you are from Telangana, but you are asking about Andhra Pradesh. Right. Question number 47. So now this is an ellipse. Say this is major, this is minor axis. So rectangle, maximum rectangle means at this point and at this point, at ends of the, so that means, so you need to draw like this now. This is the maximum rectangle. Maximum rectangle inscribed in the ellipse. Sorry, inscribed in the ellipse. Okay, inscribed in the ellipse. Okay, like this you need to inscribe A, A dash, B and B dash. This is 90 degrees. Okay, so now write down, let A1 equals to area of the ellipse, area of the ellipse equals to pi AB. This formula already we have discussed. Now A2 equals to area of the rectangle inscribed in ellipse. So it seems to be rather rhombus. Rhombus may be a rectangle also, but actually what we need to do it half into formula D1 into D2. D1 stands for diagonal. This is the diagonal, this is the diagonal. We can write half times AA dash into BB dash. AA dash is the length of the major axis, that is 2A. BB dash is length of the minor 2B. 2 gets cancel. We have 2AB. Now what we need to find out now? What we need to find out now? So now we need to find out ratio between them. A1 is to A2. A1 is to A2 is equal to pi AB is to 2AB. Here see, AB common term gets cancelled. We have pi is to 2. This is the required answer. What is Gopalan Sai? I didn't get it. We have used GeoMap. I didn't use anything time GeoMap. So clearly let me explain. I will continue that problem 48. What is Gopalan Sai? What did you say? Once again chart it. Anybody got it? What Mr. Gopalan Sai said? Okay. Fourth option. 48. Question number 48. Okay. Thank you, Dishwant. I couldn't understand. Okay, it's all right. A tangent drawn to the ellipse x square upon a square plus y square upon b square equals to 1. Okay, I got it. Okay, thank you. So I already told you before earlier itself only, but our channel is meant for providing the free education to all the children. That's all. So definitely we will keep our promise. Thank you. Meets the axis in A and B, then the least length of the portion of AB is first option mod of A minus B. Sorry, obviously A will be greater. You should not worry. A minus B. Second, 2 times A minus B. Third, A plus B. Fourth option, twice A plus B or 2 times A plus B. So it might be Lalit apply. No problem. Right. A tangent drawn to the ellipse meet the coordinate axis in A and B. The least length of the portion of AB you need to find out. So this question actually already we have discussed in maxima and minima. The same question can be applicable for even for this chapter also. Thank you, Vamshi. So one more thing I would like to share with you. If I give any wrong information, definitely this is not good for our channel. This is our channel, isn't it now? So that's why I don't disclose all these things unless I know the genuine information. If I actually make a video on this one on Eamcet, maybe postponed or maybe conducted like that, definitely I will get more subscribers. But that's not, we should not do like that, because official website, you need to go to the official website, then you need to decide. That's all. That's very important. Whatever Vamshi Krishna Yadav said, absolutely correct. So simply we should not say without having any genuine information from our official government sector. 48th question. A tangent, sorry. 48. 48. Solution. We need to check now. Okay. So let us draw a figure. So a tangent is drawn like this. Drawn at this point. Drawn at this point. Meets x-axis at A, y-axis at B. This is center C. The least length of AB we need to find out. Least length of AB we need to find out. Ashwaradi, what happened to you? Yourself also started discussion. Leave that matter. So this point is P of theta. Now write down. Equation of tangent to ellipse S is equal to 0 at P of theta is the parametric equation. Is what is that actually? Parametric equation is x upon a cos theta plus y upon b sin theta equals to 1. So to find out actually this length, AB length, means we need to find out CA, and CB we need to find out. That means in order to find CA is called x-intercept of this line, CB is called y-intercept. To get x-intercept, put y is equal to 0. Put y is equal to 0. If you put y is equal to 0, this becomes 0. X by a cos theta equals to 1. Now x equals to, we get a upon cos theta. This we get a sec theta. Therefore, this is nothing but CA only. CA value obtained. So next, this will be right angle. Put x is equal to 0 to get y-intercept. This will be 0. Y upon b sin theta equals to 1. So y equals to b upon sin theta, whose value is b cosec theta. This means CB. Now we need to find out AB. So AB square is equal, from Pythagoras theorem, we can write CB square plus CA square. That will be, CB will be a square secant square theta plus b square cosecant square theta. Now AB equals to root over a square secant square theta plus b square cosecant square theta. So now I give one short tip. The minimum value of a square secant square theta plus b square cosecant square theta is a plus b whole square. This will be useful for maxima and minima, periodicity, both chapters also. Right. That means in order to find out the minimum value of AB, least value of AB, that is equal to AB minimum. AB minimum is equal to the minimum of this value, root over So we need to write this value, a plus b whole square. So we get a plus b. This is the answer. Okay. Right, a plus b. Third option. Now 49th question. 49th question. 49th. Okay. Right now. Right. The greatest, this is very important problem. The greatest distance from the greatest distance from the center Shreya Rachakonda, Bobby Chauhan, from the center of the ellipse x square upon a square plus y square upon b square equal to 1 to any normal of it, any normal of the ellipse is first option a minus b, second 2 times of a minus b, third a plus b, fourth twice a plus b. This is the question. First read the question. Right, the greatest distance from center of the ellipse. Center of the ellipse is origin 0, 0 to any normal to the ellipse. First we need to find out any normal, equation of the any normal. Avinash, please be cool. Now the equation of any normal at P of theta is given by the formula we have, the parametric equation of the normal. So next what should we do means, we need to find out the perpendicular distance from origin to that point. Then after that, the greatest the distance, we need to maximize the perpendicular distance from center. Center means which is 0, 0. So let us do it now. The greatest distance from the center. Center means origin to this ellipse. Any normal on it is we need to find out. Right. Srija, 49th question. 49th. Solution of 49th. Equation of normal at P of theta to the ellipse. To the ellipse. Ravisheshu, your brother had been away, had been kept away. Right. Equation of normal at P of theta to the ellipse is ax upon cos theta minus by upon sin theta equal to a square minus b square. This is parametric equation or parametric form. Parametric form. Am I correct now? Now, distance from, so this can be rewritten like this also. A sec theta x you can write minus b cosec theta minus of a square minus b square equals to 0, which is in the form of ax plus by plus c equals to 0 form. General form of a straight line we have written. Now, distance from say this is P, C 0 comma 0 center to normal equal to formula. So mod of this will be minus of a square minus b square c by root of a square plus b square. This is a square secant square theta plus b square cosecant square theta. This will get it now. This equal to a square minus b square upon root over a square secant square theta plus b square cosecant square theta. We need to find out actually here the greatest distance we need to find out. Greatest distance means it should be minimum value of this one we need to write. See, already we have minimum of a square secant square theta plus b square cosecant square theta equal to a plus b whole square. To get here P max a square minus b square upon root of a plus b whole square. This is a square minus b square means a plus b into a minus b upon square root of a plus b whole square is a plus b. A plus b gets cancelled. So absolutely correct you are a minus b. A minus b the right option. What? Arshit Reddy. Okay, I stay at Hyderabad. First option the right option. Okay. Half century. Question number 50. Okay. Half century question. Right. The locus of midpoint. The locus of midpoint of portion of the tangent includes between the axis drawn to the ellipse x square upon a square plus y square upon b square equal to 1 is the locus of the midpoint of the portion of the tangent includes between the axis drawn to the ellipse x square upon a square plus y square by b square equals to 1 is first option x square upon a square plus y square by upon b square equals to 4. Second option a square upon x square plus b square upon y square equals to 4. Second option a square upon x square plus b square upon y square 1 by 4. Fourth option x square upon a square plus y square upon b square equals to 1 upon 4. 1 upon 4. First read the question, try to understand the concept, then do the problem. Put on the paper and with the paper and you try to check yourself also your answer. The locus of the midpoint of the portion of the tangent include between the axes drawn to the ellipses. So that means first of all we need to find out equation of the tangent at p of theta, at which point it cuts x-axis and y-axis we need to find out. Let us say the midpoint of the intercept between the coordinate axis be p of x1 comma y1. Then we need to find out x1 comma y1. From that we need to eliminate theta so that we get the eliminant. That eliminant is our required answer. Mahesh Babu. Okay. Let us do it now. 50. So this is an ellipse. So draw the tangent like this at p of theta meets at say a, b. This is a portion between the axis. Let us say rx1 comma y1 midpoint. Locus of this r we need to find out. Okay, now the solution. First equation of tangent at p of theta is x upon a cos theta plus y upon b sin theta equals to 1. Say equation 1. So now put y is equal to 0 to get x-intercept. This becomes 0, x becomes a upon cos theta. That means the coordinates are a upon cos theta, comma 0. Put x is equal to 0 to get y-intercept. So y equals to, we get b upon sine theta. That means b coordinates will be 0, comma b upon sine theta. Now we need to find out midpoint of the line joining A point and B point. We need to find out. So now let us say R of x1 comma y1 be the midpoint of AB. That is x1 comma y1 equals to, you get like this, a cos theta plus 0 by 2, a upon 2 cos theta, comma b upon 2 sin theta. You will get it. So now equate these two. Now x1 comma y1 equals to a upon 2 cos theta. This is b upon 2 sin theta. So we have x1 equals to a upon 2 cos theta. Cos theta equals to a upon 2x1. Say equation 1. Similarly, sin theta equals to b upon 2y1. Say equation 2. Eliminate theta from these two equations now. Eliminating theta. So from 1 and 2. Cos square theta plus sin square theta equals to 1. Am I correct now? This is an identity. So we get a square upon 4x1 square plus b square upon 4y1 square equals to 1. This can be written as a square upon x1 square plus b square upon y1 square. Multiply 4 on both sides. You get 4. Therefore, locus of R x1 comma y1 is, instead of x1 x, instead of y1 y, let it be replaced. So we get a square upon x square plus b square upon y square equal to 4. This is the locus of the midpoint of the portion intercepted between the coordinate axis of the tangent to the ellipse. Okay. Let us take a small break. After that we shall continue. Option 2 is the right option. Option 2. Option 2. Question number 51. 51. Question number 51. Locus of the poles of chords of poles of chords of 2 and 3 by 2 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 by x square upon a square plus y square upon b square equals to 1, which touches the director circle. The director circle. X square plus y square equal to a square plus b square is first option x square upon a square plus y square upon b square equal to a square. Second, x square upon a square plus y square upon b square equal to minus a square. Third, x square upon a square plus y square upon b square minus 1 upon a square. Fourth, x square upon a square plus y square upon b square equal to 1 upon a square plus b square. So better this type of questions are need to remember as a shortcut. This we need to remember as a shortcut formula. Shortcut formula instead of doing. But I will explain the method, don't worry. The locus of the poles of the chords of x square by a square plus y square by b square is equal to 1, which touches the director circle x square plus y square equal to a square plus b square is. Yes, option 4 is the right option, absolutely correct. Option 4. But how to do? Let me explain the method. Let p of x1 comma y1 be the pole. Then equation of the pole with respect to the ellipse is xx1 by a square plus yy1 by b square equals to xx1 by a square plus yy1 by b square equals to 1. It is a tangent to the circle. Tangent to the circle means condition for tangency we need to apply. What is the condition for the tangency means? The perpendicular distance from center to the that polar equation should be equal to radius of the circle, that is root of a square plus b square. Then by simplification you will get fourth option is the right option. So now this is the shortcut. Note down now shortcut. Shortcut formula. This you need to remember. Locus of poles of chords of the ellipse. X square upon a square plus y square by b square equal to 1, which is a tangent to the director circle. X square plus y square a square plus b square is x square upon a square plus y square upon b square 1 upon a square plus b square. This remember. Okay. What is the question number? Rayapudi Rajesh. What is the question number? Right. 52. 52. Locus of the poles of chords of an ellipse x square upon a square plus y square upon b square equal to 1, which touches or is a tangent, touches the auxiliary circle, is first option x square upon a square plus y square upon b square equal to 1 upon a square x square upon a square plus y square upon b square minus 1 by a square. Third, x square upon a square plus y square upon b square 1 upon a square plus b square. Fourth option, x square upon a square plus y square upon b square minus 1 upon a square plus b square. Yes, option 1, absolutely correct. Who is Mr. Nani Reddy? What does it mean by Nani Reddy? Okay, Praveen. Okay. Absolutely, your expectation is correct. 1 is the correct. This is also a shortcut formula. Shortcut formula. Locus of the poles of chords of okay, chords of x square upon a square plus y square upon b square, which touches or which is a tangent to the auxiliary circle. X square plus y square is equal to a square is x square upon a square plus y square upon b square equal to 1 upon a square. It is also a ellipse. So you need to remember this one. Right. 53, 53, 53. If alpha plus beta equals to pi by 2, if alpha plus beta is equal to pi by 2, then the locus of point of intersection point of intersection of the tangents drawn at alpha and beta on the ellipse x square upon a square plus y square upon b square equals to 1 is first option bx plus ay equals to 0, second option bx minus ay equals to 0, third 2bx minus ay equals to 0, fourth option bx minus 2ay equals to 0. This is the question. If alpha plus beta is equal to pi by 2, then the locus of the point of intersection of the tangents drawn at alpha and beta to the ellipse x square upon a square plus y square upon b square equals to 1 is. That means I already in the introduction part only I have discussed the point of intersection of the tangents drawn at p of alpha and p of beta. So you might have recollected. Please go through your notes. Okay, Siddhartha, right. That is a times cos of alpha plus beta by 2 upon cos of alpha minus beta by 2, comma b sin of alpha plus beta by 2 upon cos of alpha minus beta by 2 is equal to, we need to say x1 comma y1, locus of x1 comma y1 we need to find out. Well, let us see now. Alpha plus beta equals to pi by 2, then the locus of the point of intersection of the tangents drawn at alpha and beta on the ellipse s is equal to 0 we need to find out. Right. (53). So the point of intersection of tangents drawn at p of alpha and p of beta, q of beta, is, see, a cos alpha plus beta by 2 upon cos alpha minus beta by 2, comma, this is a sin alpha plus beta by 2 upon cos alpha minus beta by 2. This is the formula. Now what is given here? Here given that alpha plus beta is equal to pi by 2. Substitute in this one. So let us say x1 comma y1 becomes, whose locus need to be evaluated now here, a cos 90 by 2, 45 upon cos of alpha minus beta by 2. Alpha minus beta is not given, so this will be, sorry, b sin 45 upon cos alpha minus beta by 2. So now cos 45 is 1 by root 2, 1 by root 2. So that we can write, see, this is my book. Okay. Cos 45 is 1 by root 2. So we can write a upon root 2 times cos alpha minus beta by 2 b upon root 2 times cos alpha minus beta by 2. So now, yes, x1 equals to this one and y1 is equated to this one. So that means, let us write now here, x1 comma y1 equals to a upon root 2 times cos alpha minus beta by 2 comma b upon root 2 times cos alpha minus beta by 2. Okay. So comparing these two, we get cos alpha minus beta by 2 equals to a upon root 2 x1, say equation 1. In the similar manner, comparing these two values, cos alpha minus beta by 2, here also same, b by root 2 y1. Actually, cos alpha minus beta by 2, cos alpha minus beta by 2, same. Right now, we get a upon root 2 x1 equals to b upon root 2 y1. Root 2 gets cancelled. By cross multiplication, bx minus ay1 equals to 0. Therefore, locus of x1 comma y1 is bx minus ay equals to 0. This is the answer. Second option is the right option. Am I correct now? But you need to remember the concept. Unless and until you know the point of intersection of the tangents, so you cannot find out. Then you need to find out alpha plus beta, and we need to check it now. Understood now? So this is the answer. So thank you, all of you. See you. Bye bye. Have a nice day. Right.